Before we get into the speakers, I'll just a small background to say this is one of the just about the finishing events we are doing online in Codex, but there's still a few to come. Today's is one, as we are reaching the project conclusion mid this year, we are getting to significant results. The focus today is on a topic that is central to European farming, what digitalization, how digitalization can deliver, what are the costs about economic, environmental, and social dimension of digitalization in farming. Digital tools promise higher productivity, reduce environmental impacts, increase resilience. But as Code has shown, digitalization is not a one-size-fits-all solution. Depends on farm size, production system, skills, governance, and access conditions. So what we're bringing to you today is research evidence, case studies from our living labs. Our colleagues from INRAE will present a number of deliverables, and they will also have the contribution, much appreciated, from DG Agri from the European Commission. But I think before that, as some of you have been into the Codex meetings before, others don't, I think it's important to provide a very general background by none other than our main professor, but I will leave Professor Brunori, but I will leave, as I tend to overrun myself, I will leave Merveille as maître de cérémonie for the next part of this session. So without further ado, Merveille, the floor is yours. Thank you.
Thank you very much, Serafin, and good morning, everyone. It's a pleasure to welcome all of you today for one of the last sessions of the Codex Knowledge Accelerator. So I'm Merveille Ntawashe. I'm the project manager of Codex from ADO. And as Serafin was mentioning, I will be leading you through the sessions. So we have a rich program ahead, and we will jump right in and welcome the first speaker of the day, which is Professor Gianluca Brunori, who is a professor at the University of Pisa and also the coordinator of Codex. So Gianluca is an expert in food policy and sustainable and rural development, and he has over 30 years of experience in leading international and European research projects on food policy. And today he will introduce how Codex assesses the real-world impact of farm digitalization, and he will reflect on how on digitalization as a major shift for farmers in agriculture, and why the right governance matters to really make sure that the digitalization won't add pressure or deepen inequalities in agriculture. Gianluca, the floor is yours.
Thank you very much, Merveille. I'm going to share my screen. And so welcome to everybody. My introduction here will explain how we have approached this matter of costs and benefits. And we start from the observation that digital technologies are not like other type of technologies because they are distributed in the space and in the time. So each, let's say, technology, sensor, software, etc., is connected to a myriad of others items. So in order to evaluate it and evaluate its costs and benefits, we have to consider a broader set of connections. And this has several implications for the methodologies. We understanding that there is a complexity of different pathways of digitalization, we have adopted an approach based on living labs. So identifying a context, talking with stakeholders, and together with them co-developing ideas about the digitalization in a specific application scenarios, and also evaluating costs and benefit at different levels. Also following the call, we have try to have a systemic and let's say a broadened approach, considering social, economic, and ecological impacts. And we already have, as you can see, published several papers on these aspects. On the beginning, just with the literature review, but after also for assessing the perceptions of farmers and stakeholders about digitalization. Our conceptual framework based our approach on 3 levels. The first level is the process, the business process. At farm level, we analyze the process that is going to be digitalized. The second level is the digital ecosystem, considering all the interconnections, not only at farm level, but outside the farm gate, and understanding what are the cost and benefit generated from the farm to the external ecosystem, and from the ecosystem to the farm. And then the third level is the socio, cyber, physical, and ecological system. So a broader approach to these systems that in digitalization occur. And also in this case, we have published a paper on agricultural systems quite recently. So in terms of the process, as I say that the processes can be very complex, and each time you introduce a technology, this technology affects a set of relations, not only at a technological level, but also at a social level, because it introduces new type of actors and maybe exclude other type of actors. And we have developed a technology and a methodology to map these changes. And so we analyze the process as is, and then we analyze the process after digitalization. This is a tool to discuss with living labs about the process. So to try to consolidate stakeholder perceptions into maps, graphical tools that can be used to analyze. And this can help us also to see where the cost and benefits are generated, because each box you can see there can be digitalized, and so it can generate costs and benefits. But then we have assessed the digital ecosystem. With the digital ecosystem, we mean a set of relations that provide resources and capabilities to farmers and to the actors involved in farming. And in particular, we look at the governance, we look at resources of any kind, and we look at actors that put together these components. And so we have seen that in different living labs, we have different patterns of relations that create a different level of conduciveness of the digital ecosystem, and so generate different types of costs and benefits. The third level is at a socio-ecological system. In this case, we look at a broader regional or societal level. We again consider governance systems, resources, in this case considering natural resources, and also intellectual resources, etc. And then we identify the processes as a focal action situation, looking at how these situations can affect the broader system, and so how to consider sustainability of these systems in a broader view. So with this, I would like to stop here, because we will have several presentations that will show how we have addressed these aspects, and I wish you a good day. Thank you.
Thank you very much, Gianluca, for this great introduction on what Codex is doing and what it's trying to do for digital agriculture. So now we will move to our second speaker, Miguel Fernandez from the European Commission at DG Agri. So Miguel is a national expert in DG Agri, working on the unit dedicated to data governance and digitalization of EU agriculture. And today he will explore how the cost, benefits, and trade-offs of digital farming tools can be assessed to better support informed decision-making at EU level. Please, Miguel, the floor is yours.
Yes, thank you very much for the introduction, and good morning, everyone. I will try to share my screen. So just 1 second. Okay, I think it should be working
Yes,
now.
it's working. Yes.
Perfect. Thank you for confirming. So, yes, my name is Miguel Fernandez. I work in DG Agri, Unit A4, which is the unit dealing with data governance and digitalization. And over the next 10 minutes, I will share a short update on the EU policy landscape for digitalization in agriculture. And I will also reflect a bit on the value of digital tools, together with some examples of what could be, let's say, potential trade-offs. So let me maybe start with the broader policy context, and here the vision for agriculture and food recognize the potential of emerging technologies to enhance different farming operations, and also to transform the way we produce food, and we mean transform it in a way that benefits the environment, the climate, and society. So we think that here the digital tools, and we have a lot of different digital tools, as you know, from satellite monitoring systems to farm management software, sensors, and of course now artificial intelligence. But we think that these different type of solutions are no longer, let's say, a nice to have. These are increasingly more the infrastructure that lets farms and public administrations to manage complexity. And here, complexity, we mean climate volatility, labor constraints, market uncertainty, so different challenges, let's say, that our farmers are facing. But in any case, our starting point stays the same. We think that the digitalization has to be farmer oriented, and that tools need to fit farmers' real needs and real constraints. And those constraints differ a lot across different sectors, and also depending also on the specific farm types. So to understand where we actually stand, which technologies are being adopted, what barriers farmers face, we conducted with the GRC a study on the state of digitalization in the EU agriculture. And this is a study based on a survey of almost 1,500 farms in different member states, in 9 member states. And the study confirms that the digital transition is advancing, but we observe that well, different findings. For instance, on the one hand, there are multiple technologies that are being adopted at farm level, as I was saying before, from FMEs to cameras, sensors, and even in some cases robots. And we also observe that in general, livestock farms are outperforming crop farms in this overall digital uptake. But we also observe a clear, let's say, two-speed digitalization. So on one hand, general IT tools, email, basic office software, communication apps, this type of solutions are being widely adopted. While on the other hand, the tools that are more farm specific, or so these farm specific technologies that we can see on screen are much less common, particularly among smaller farmers. So for instance, precision application technologies, decision support systems using satellite data, advanced livestock monitoring, we observe that there is this two-speed digitalization and across the EU. So this brings us to this core question that we were discussing before. What value does digitalization create, and in particular in agriculture? And well, we think that here, of course, digital tools can create real value, but the value is conditional. It depends on the context, it depends on the governance, the skills, the level of interoperability, connectivity. So it depends on an enabling environment where these technologies can be used, the data that is being generated can be shared, can be reused, and the benefits of these solutions, of these digital technologies, can be also retained sufficiently by farmers. So when we say value, we think it is important to be precise. Value for whom, in what time frame, and also at what cost. So maybe a useful way that we could use to structure this, let's say this answer could be around the three value channels, as we can see here on this slide. One could be farm performance, the second one could be environmental performance, and then the third one on this more social or territorial performance. So maybe on the first one, on the farm performance value, many times I think we start from here. No, can digital tools improve the margins, the productivity, risk management, time use? And in practice, I think value often comes from better decisions rather than from a single big jump. And it is also it contributes to this value generation, the fact that these tools can improve the situational awareness. So for instance, in increasing the decision support or allowing to trigger certain actions when there are certain weather related events, no? And then a third aspect that can also create value in this context is the possibility to reduce paperwork, so to reduce the administrative burden linked to certain activities at farm level, but only if these systems are designed in a practical way, both for farmers and for administration. So this could be the first one. Then the second one, as I was saying, would be more the environmental value. And here, of course, many digital tools can support reduced input intensity and can also facilitate better targeting, fertilizers, water, plant protection products, etc. And then in the second stage, let's say, these tools can also improve traceability, monitoring, and verification. So, for instance, using technologies such as digital farm passports or business wallets, this can also be very, very relevant in order to prove, let's say, these specific practices. And then the third one would be more on the social and the territorial value. Here, we see value when these digital tools improve the safety, reduce hard manual work, and make the farm work more attractive, no? Especially when or where labor is hard to find. But at the same time, as we were discussing, there are, of course, a number of trade-offs, no? And I see, for instance, three that repeatedly come up across different member states, projects, and also stakeholders dialogues. And as you can see on the screen, the first one is this performance versus complexity, no? Or these better results versus more complexity, no? Because of course, if these tools add extra steps, extra screens, or systems do not work together properly, farmers may lose more time and may lose trust in the process, and this value may even disappear or decrease if farmers need to spend more time managing the tools due to, for instance, a lack of interoperability or the complexity of the tools or the need to manage multiple tools. No, so here we see one clear trade-off. Then the second one could be more this unequal uptake, the digital divide, no, that I was mentioning before. And of course, here we have different key fundamental aspects: connectivity, skills, support services. These are fundamental to create this enabling environment and can differ widely across regions in the EU. So a tool that works well in one area may not work in another area if these basic building blocks, let's say, for the digital transition are missing. And then the third trade-off that I wanted to mention is related to data governance, trust and sharing. And here, indeed, well, we see a digital agriculture is increasingly a data economy. And in this context, value increases when data can move between different devices, between different machines, software, cooperatives, advisors, supply chains, etc. But at the same time, and as I said before, farmers need to retain part of this value, need fair terms when it comes to this data economy and data sharing. And this comes, for instance, with the ability to switch tools, to share data, to reuse data, and to have a proper level of interoperability across this use of mixed equipment. So this would be on the value, but now I would like to quickly mention a few aspects on how the EU is supporting this value creation and supporting also digitalization. So first, I would like to mention the Common Agricultural Policy, the CAP, which remains a fundamental instrument to support farmers in accessing and using these technologies. And as you know, in the current CAP, digitalization is a key part of the cross-cutting objective on modernizing agriculture and rural areas. And we are following, for instance, the digitalization strategies that member states have developed for the very first time as part of their CAP strategic plans, and where they explain how they support this digital transition at national level. For this, they have a portfolio of different CAP measures at hand, at disposal. For instance, they can promote digital infrastructure, they can support digital infrastructure, training, skills, the adoption of advanced technologies, including precision farming via investments. And we think that this is fundamental, no? As I was saying, the possibility to create and to support this enabling environment, especially for small and medium-sized farms to take up and to make effective use of these technologies, while also, of course, unlocking the full potential of data. And to make this work well, we also need, let's say, clearer ways to track what is being supported and what results we get. And in this context, I would like to draw your attention to another study that was published a few months ago in collaboration with the Evaluation Help Desk. And this is a thematic report on assessing digitalization under the CAP strategic plans, where you will find interesting aspects such as, for instance, first, the common definition for digitalization in agriculture at EU level, which may help to harmonize what we understand as digital activities within the CAP. Then second, you will also find a methodology to classify CAP interventions as digital interventions when certain requirements are met. And then third, once a CAP intervention is identified as digital, the report also includes a proposal on how to classify these interventions that contribute to digitalization in different types of categories based on the nature of the intervention. So we expect that this work will be relevant not only in the current CAP, but also in future frameworks. And talking about future frameworks, I would also like to say a few words on digitalization under the next multi-financial framework, under the next MMF. And here, well, first of all, we know that the EU is facing significant challenges, but in this context, the CAP will remain a key element of the EU policy and the next multi-financial framework. As part of this next MMF, the CAP will be integrated into the national and regional partnership plans with dedicated chapters for each member state. And with this structure of a single fund approach, well, the EU is aiming to simplify the framework and enhancing the efficiency and, let's say, the manageability for national administrations of CAP support and the rest of the programs. But in any case, the main or the core principles are kept. And with this, we expect to give further flexibility to member states to program interventions that can accompany both the green and the digital transition. At the same time, this new structure will allow to generate better synergies across the different EU funds and will offer also a more simplified delivery. And I would like also to mention that as part of this discussion on digital, a powerful competitiveness under Pillar 2, it's also available with the intention to boost and secure supply chains, to boost technologies, secure supply chains, and scale up innovation, which we consider is also very relevant in the context of the digital transition. So then, the CAP, well, the CAP is not the only instrument supporting digitalization, as you know, of course. And in this CAP strategic plans, member states identified synergies with other EU instruments. And here I would like to mention, of course, research, because it has a pivotal role to demonstrate the effectiveness and to ensure the acceptance of an uptake of technologies and different projects, including different Horizon projects, including of course, Codex are working on this, and we had the opportunity to discuss several times in the past, and the outcomes of the project are being very well received from a policy perspective. And in addition, I would like also to mention the recently launched the Partnership Agriculture of Data, together with the initiatives funded under the Digital Europe program, such as the Common European Agricultural Data Space, and also the Digital Innovation Hubs, the Agri-Food test and experimentation facilities on the use of AI that further complement this digital landscape. Finally, as you know, funding alone is not enough, is not sufficient. Farmers also need a fair and workable framework for data. And there are a number of legal initiatives that are supporting digitalization, not only in agriculture, but with a wider, let's say, horizontal approach. And in the framework of the European Data Strategy, we have, as you know, the Data Governance Act, the Open Data Directive, the Data Act, etc. But I would like to focus on the most recent novelties, as we have discussed the legislative framework previously in the past, in previous webinars. So here, first of all, the Data Act has recently started to apply in September 25, and the Commission has been working on model contractual terms for business-to-business data access, use, and sharing. And these model contractual terms were recently published, so we expect that these non-binding MCTs can support data sharing in the data economy in the EU, and including, of course, also in agriculture. And finally, at the same time, just to mention that related to this, to the Data Governance Act, Data Act, and the EU acquis in more in general, there is a major ongoing consolidation exercise that is called the Digital Omnibus. This was proposed in November last year to consolidate 4 of the main data legislations into one single instrument, the Data Act, and is part of a broader digital package the Commission with this package expects to let's say keep the central rules of these data legislations while at the same time reducing a certain burden linked to specific provisions. So with this, I conclude my presentation. I would like to finally just to highlight once again the potential of new technologies to reinforce the competitiveness, the sustainability, and the resilience of EU agriculture. We have seen that the current and future policy framework do support the digital transition in multiple ways, with an enabling legal environment, with research and innovation, advice, targeted investment, and different CAP interventions and others. But this value, we think, emerges only when the technology is part of a functioning enabling environment. And for this reason, we consider it very important to continue working on aspects such as connectivity, data sharing, advisory services, interoperability, etc. Thank you very much. With this, I conclude my presentation. Thank you.
Thank you very much, Miguel, for this really clear presentation. And what we can clearly see is that new technologies can significantly enhance the competitiveness and sustainability of and resilience of EU agriculture, but only when they're supported by the right framework, the coherent policies, and also some solid infrastructures. So now we will turn back at some research that was led in the Codex project with a joint presentation from Alexia Gobrecht and Véronique Belon-Morel, both from the French National Research Institute for Agriculture, Food and Environment. So Alexia is a research scientist focusing on environmental and social impacts of digital technologies in agriculture. And Véronique is an agronomist, engineer, and researcher. And she plays a key role in structuring research and innovation around digital agriculture, agroecology, and experimental work through living labs. And so today they will be presenting some research they led in the Codex project on the cost and benefits of digitalization in agriculture. Please, the floor is yours.
Thank you so much, Merveille. I will start this talk, and thank you, Gianluca and Miguel, for setting the frame and how digitalization can help farmers. But actually, I mean, it's very important also to see how these digitalization transforms processes like, for instance, pesticide spraying or irrigation or fertilization into digitalized process. And this transformation can have either positive or negative impacts. And it's also our responsibility to make those impacts clearer to the farmers so that they can choose these digital technologies. Going back to Gianluca's presentation, we will focus here on the level 1, which is how the process, the agricultural processes are affected by the digital technologies and digitalization. So our point at this level 1 was to capture this transformation and to objectify the costs and benefits in the 3 dimensions of sustainability, the environmental, economic, and social user-centered dimension. So regarding environmental assessment, we carried out a life cycle analysis, which are very common and displayed approaches. Regarding economics, our colleagues from ELGO carried out a multi-level economic approach. And regarding the social and user-centered dimension, we had to build a new multidisciplinary approach with colleagues from James Hutton, from BSc, from Hohenheim and INRAE research centers. So we had to collect data in the living labs. Gianluca told us that we had 20 living labs in Codex all over Europe. And we collected, with the help of the Living Lab coordinators, quantitative data in order to process the environmental and economic, to proceed to the environmental and economic assessment. So this was carried out in 11 Living Labs. And we also carried out qualitative data collection throughout interviews to be able to assess the social and user-centered impacts. So the type of digital agricultural technologies were IoT sensors, digital marketplaces, drones, and automated systems, but also farm management information systems or decision support systems. And these were applied to various agricultural sectors like viticulture, arable crop productions, any type of production, livestock, greenhouses, and orchards. And so the environmental indicators that came out from these studies were classical indicators from life cycle assessments, which are a lot of midpoint or endpoint indicators. We also issued economic indicators, classical economic indicators. We will go through the insights a little bit later. And regarding the social and user-centered assessment, we are very coherent with what Miguel said, which are that we had impacts on human well-being, on the work, and also on the social integration of the farmers. And that's what we will measuring through this data collection. So now I will give the floor to Alexia to get further into the various insights we have got from all these assessments.
Okay, thank you very much, Veronique. So I will give some examples of the findings we have found in the 3-dimension coming from the data collected in the Living Labs. It's still an ongoing process of analysis, but the idea is to show that with this data we can provide some interesting discussion subjects. So regarding the environmental analysis, the message is quite clear, and it confirmed also the publication we made on the review paper on environmental assessment of digitalization, that digital technologies, when they are embedded in the agricultural process, they can reduce the environmental impacts, and in nearly most of the impact categories. However, we can sometimes a little bit restrain this positive message, because we have found that in some studies the impact was quite low. The difference of impact was quite low, and sometimes the difference were within the range of uncertainty. And also, when there is a reduction of impact, it's mainly related to optimizing the inputs. What we also found out is that the digital technology is sometimes responsible of the increase of impacts in some categories, and these categories are directly linked to the technology itself, meaning that we need some resources to build them, and we need some energy to make them functioning, and so this increases the impact. But the second message is that finally, when we look at the contribution of the digital technology parts, the hardware, the software, the usage, the end of life, etc., this life cycle of the digital technology, we can see that this digital technology contributes very little, or sometimes nearly no, compared to the contribution of the agricultural process itself. And we know agriculture is a sector that has a high environmental impact. Okay. However, this digital technology, when it's embedded in the agricultural process, it can act like a catalyst, reducing the impacts by transforming the agricultural process through, for example, optimizing the inputs like water, energy. So it's the adoption of the digital technology that will have a positive impact at the end. From the economic cost and benefits analysis and the analysis of the quantitative data collected, here are some examples of outputs that the transition, the digital transition is always a balance of drivers and barriers. Adoption can be driven by operational savings or lower workload. However, there are a lot of hurdles. There are often high investment costs or maintenance costs or recurring fees. There are also a certain number of hidden costs, like non-monetary costs such as extensive training or learning time, and financial risk also due to the fact that the system is sometimes hard to integrate in the process, and also technology obsolescence. The other point is that, of course, these results are very context dependent. It's also the case for the environmental results, which vary significantly by farm size or production type, or also type of technology. And finally, on the social human-centered costs and benefits, as Véronique said, we had to first understand a little bit what was behind these social costs and benefits at farm level. And the first thing is that we found that digitalization is not only a technical transformation of the system, but also a social transformation, and which manifests in the three interconnected domains: the individual well-being, the work organization, the social relation within and beyond the farm. And so the analysis of the 24 collected interviews allow us to describe these benefits here in green and costs. So to give like a grid of lecture of analysis of the lived experience of farmers when they use digital technologies. So we are still analyzing all this material, but here are some examples of the findings. First of all, precision agriculture and traceability are often clear winners according to farmers, as they provide efficiency gains. But these type of technologies or usage are data-driven activities, and we found that they capture attention through monitoring dashboards, responding to notification, troubleshooting, coordinating with service providers, posting content, for example. And all these small but constant tasks enter in competition with the field work, with the rest of personal life. So again, there are some trade-offs to find. And we also observe the clear autonomy paradox. We see that digital tools empower farmers at the level of decision-making, but this empowerment is also structurally coupled with growing dependency of platform, infrastructure, service provider, specialized knowledge. So again, sometimes we found something positive and something negative on the same subject. Overall, we see that digitalization should not only be understood as a neutral support of farming, but also as a process that reorganizes the work, reorganizes the responsibility and the power relation within the agricultural system. So to conclude, digitalization is a journey characterized by real trade-off. Miguel was saying that also before. We gain in resource efficiency, but increase in operational complexity. So trade-offs between efficiency and complexity, trade-offs between profitability and investments, trade-offs between autonomy, better control, through data, and yet facing dependency to service providers. And finally, we can increase well-being, reduce workload, but it is often replaced by a new form of mental strain. So as I said, this work is still ongoing, but the idea here was to give the floor to the living labs, with which we have collaborated to extract more detailed results on the cost and benefits. And just before I thank you for your attention, I want to thank all the partners involved in this work package. Thank you.
Thank you very much, Alexia and Veronique as well, of course. And as Alexia just mentioned, now we will move to the practical part of the program, and we'll look at the lessons learned from two of the Codex Living Labs, where they did the analysis on the cost and benefits of the digital tools that they're doing in their living lab. And to start off, I will first welcome Simona Stoyanova to take the floor. And Simona is a PhD candidate and researcher at the University of Ljubljana. And her research focuses on the use of ICT, IoT, and machine learning for precision agriculture, and with a strong emphasis on sustainability impact assessment. And today in her presentation, she will introduce the Slovenian Codex Living Lab and share some insights from a case study on the costs and benefits of digitalization that they did in the demo farm. Simona, the floor is yours.
Thank you so much, Marvei, for that introduction. Good morning, everyone. My name is Simona Stoyanova from University of Ljubljana, Faculty of Electrical Engineering. I'm really glad to be here with you today and to be able to present our living lab called Smart Villages Network from Slovenia. So I will give you an overview about our living lab, then I will explain our two demo farms, and I will finish with some concluding remarks. Our living lab was developed as part of our research work on different European projects and initiatives, some of which you can see here on this diagram. They all complement each other and have the same goal, creating smarter and more sustainable rural communities. The Living Lab connects different stakeholders, including farmers, researchers, technology providers, and government representatives. Together, we co-create sustainable solutions, leveraging the benefits from technology. Our mission is to bridge the gap between research and practice in the field of digital agriculture by developing practical solutions for real-life challenges. Next slide, please. So the focus of our living lab is digitalization in viticulture and beekeeping. So more precisely, we are integrating IoT solutions in wine and honey production with the goal to enhance sustainability. Typical challenges for winemakers in the northern region of Slovenia are very rugged terrain, which creates microclimate. This means that the climate is significantly different in different parts of the same vineyard. This requires different treatments and actions. Also, we have been testing different network coverage that is appropriate for this terrain. In the beekeeping case, the challenges are mainly related to the remote location of the apiaries, and on the other hand, the need of the beekeeper for real-time and reliable data. However, in both of the demo farms, the Living Lab wants to ensure a holistic impact on agricultural practices with the following objectives: to improve the economic efficiency of the farms, to reduce the environmental impact, and to provide positive impact on the social aspect by ensuring sustainable businesses in rural areas. Moving on to the first demo farm, Doppler Winery. Doppler Winery faces the same challenges as explained earlier. So additionally, they are also transitioning into organic farming. As soon as a certain amount of rain falls, organic spraying must be applied to the vines in order to prevent diseases. That is why it is very important to have information on the amount of rain at the exact micro location. Under such conditions, conventional weather stations which deliver data for the entire farm are not adequate for this typical hilly terrain. In order to address these challenges, the winery developed a distributed IoT network of sensors for collecting various viticultural parameters. So more precisely, the system includes sensors which are measuring microclimate, soil moisture, rainfall, and leaf wetness. The sensors are placed on different locations, collecting data from different places of the vineyard. Collected data is then transmitted through LoRaWAN connectivity chosen as the most appropriate because of its long range, low energy demand, and also straightforward configuration. A gateway on a nearby hill transmits the data to a server, requiring only a Wi-Fi connection. Collected data from the sensors is stored on ThingsBoard platform, which represent an open source platform enabling real-time data access and visualization. In addition to this, the data is available and accessible through a mobile app, which allows end users an easily access to the information collected. The second demo farm is the beekeeping Caesar. Here we also employ IoT technology for monitoring honey production and weather conditions in beehives. The IoT-supported scales are placed under beehives on 3 different and remote apiaries. The scale operates by measuring the weight of the beehive, which serves as an indicator of honey production and overall hive activity. In addition, they also record environmental parameters of rainfall amount, wind speed, nest temperature, external temperature, and humidity. Those parameters are essential for maintaining optimal hive conditions. A key feature of the scale is the ability to transmit data in real time. So every scale has a SIM card because it uses mobile communication in order to send daily SMS to the beekeeper's mobile phone. The alerts notify the beekeeper of changes such as rapid weight increase, which indicates honey flow, or decreases that may signal potential issues. So the beekeeper can either set a time for the scale measuring the data or call the scale and get the current data immediately at any time. In addition to this, 2 more tools are added to beekeeper solution. A refractometer is used to measure the water content in honey, which ensures proper moisture level of the honey, allowing it to remain stable for long-term storage. And the second tool is a conductometer, which is used for measuring the electrical conductivity, a characteristic used to differentiate between different types of the honey. So having these tools on site, the beekeeper eliminates the need to go back to the city for doing these tests. And this represents a simple but yet a very useful and practical system for the beekeeper. Next slide. So some concluding remarks. With the implementation of the digital technology in both cases, the winemaker and the beekeeper's practices have become more streamlined and more data-driven. On a daily basis, now they receive notifications on their mobile phones, providing real-time updates on the environmental status without the need to be present there personally. So in cases of significant weather changes or adverse conditions, they can respond promptly. This automated monitoring system significantly enhanced the efficiency of their work. Achieved results in both of the cases are 20% total cost reduction, improved farm profitability, and management through optimized decision making. Environmental benefits are related to reduced water and pesticides use, minimized finer treatments, lower CO2 emissions, and improved the whole bee ecosystem. And also, we have achieved improved time management of the beekeeper and the farmer, and has social well-being through reduced workload. To conclude, in this living lab, benefits outweigh the costs. And having a clear understanding of the cost and benefits results helps to discuss and improve agricultural processes and practices among different stakeholders, which also improve trust and engagement. It also helps to transform the production system towards greater sustainability. And lastly, it helps users to take more informed and better decisions. Additionally, all this makes the rural areas more resilient, retaining local talent and potentially attracting urban residents. This brings me to the end of my presentation. Thank you very much for your time and attention, and I'll be happy to take any questions or to hear your thoughts. Thank you.
Thank you very much, Simona, for sharing this concrete analysis of your results. So we will now move to our final case study from France with Germain Tesnière from IDEL. So Germain is an engineer in agronomy, and he works on projects related to new technologies in agriculture. And today he will present lessons from the Occitanum Open Lab ship in France, which is also part of the Codex project. Germain, the floor is yours.
Thank you, Merveille. Hello, I'm Germain Tesnière from IDEL, the French Livestock Institute, based in southwest of France in Toulouse. And I will show you some interesting highlight of the things that we have done in the previous year in the Living Lab Occitanum in the dairy ship sector. So this is a very specific sector, so I'm going to present some key elements to describe our activity. The Living Lab is located in the Aveyron department in France, in south of France, in a rangeland area where the Roquefort PDO cheese is produced. And our Living Lab is bringing together, let's say, a big, large community of practice with different stakeholders. And in this diversity, we can find farmers, of course, advisors, but also milk recording technicians, the PDO organization, some livestock consultants, the solution providers, also the IT specialists and the developers who are working into the tech companies, but also in the, let's say, livestock organizations. We also involve the researchers and some project managers specialized in the dairy ship sectors. Our focus for several years now is more dedicated to digital technologies and innovations for the dairy ship sectors regarding production, but also animal welfare. So this slide is like an overview of the key events we had along all those years. This is a very long-standing collective dynamic because the sectors try to organize the research and innovation discussion itself, like a think tank since a long time now, as you can see. And for the past 5 years, we were working more in the topic of digitalization in these dairy ship sectors with the farmers. So we organized various events, dedicated workshop to express the needs and understand also the needs and the obstacles of the farmers. We had those focus groups, the farm visits, the cross visits within Codex project, and some surveys. I will present some key elements of the surveys, webinar and Farmina. So if we go deeply in the context of these dairy ship sectors, we went to a national survey like 3 years ago now to understand what kind of technologies the farmers are using and what kind of technology they would like to use in the future. And according to this national survey, the result in the dairy ship sector were very interesting because we find some interesting use of technology, but also some very good perspective for the farmers. So we choose to focus on the individual micrometers according to the farmers' interest. 3 years ago, there were around 3% of farmers using this kind of technology in their milking parlor, but almost 20% were planning to buy it in the medium-term strategy. So this is an example. I won't go into the details because there is many different brands and models, but the topic or the objectives of the individual milk meters is to be used in the milking parlor to identify the animals and to measure the specific and individual quantity of milk produced per ewe. So the farmers can have a specific data in the morning and in the evening for each milking time. And according to this first result, we went to a second survey in the Living Lab, a specific survey dedicated to the dairy ship sector, with a great number of respondents. And we find more or less the same level of users. That was quite good, but also an interesting result. There was no specific progress in the adoption of this technology. And we were asking a lot of questions regarding their opinions, their perception about the use of the technology, but also what they wanted to know about the technology to be more equipped with the information to make some choices for them. So the survey was very big, so I just pre-selected 3 questions and answers to give you an overview of this. So the first question was about the advantages that the farmer were highlighting using this technology. So for the farmer who were equipped, they were citing a lot of advantages regarding the milk production data and how they can use the data to improve farm management, to improve the performance of the farm, but also the feeding strategy of the animals. And that was very interesting regarding the following result that Alexia will present about cost and benefits. The question regarding animal welfare and health were also cited, but a little bit lower in the ranking. And one of the explanation now is because the value and the analysis of this kind of data is not enough ready to be used on farm regarding those topics. And speaking about the cost and benefits, we added a general question in the survey for the farmers to ask them if they were satisfied or not regarding their investment of the individual milk meters. And according to them, the cost of benefit ratio was quite satisfactory for most of the farmers using the technology. But meanwhile, the majority of the farmers without this technology were really unsure about whether the benefits installing the milking meters would be interesting for them on farm. So that was more or less something very interesting for us to continue to work, looking at the cost benefits in the different approaches, social, environmental, and also economic, to give them interesting information to help them understanding why they would or they would not follow this investment in their farm. So this is the last slide of the survey, but there was also a big topic about obstacles, and this is something we would like to mention also. Regarding the adoption, there was more than half of the farmers that was not planning to install this technology for now because of partially of a lack of information also, but sometimes they were also mentioning excessive cost as the first obstacle. No specific need identified on their farm, and excessive maintenance. There was also a topic, and we were also discussing in the focus group, the lack of trust and reliability about the data coming from this kind of technology. So this is the most obstacles for the farmer's point of view, but what we think also is as an interesting data from the survey is that almost a half of the farmers who didn't have this, but they are planning to do it within the 5 years and then 5 next years. So that was a little overview of what the farmers think about the technology, and Alexia will present now how we were using the framework from Codex to give more info about cost benefits approaches.
Okay, thank you, Germain. Yeah, so as I presented just before, we applied this set of activities to capture what happens at farm levels when digital technologies are adopted. So for this living lab, we conducted, so Mauro conducted 2 farmers interviews. So it's in-depth interview, and the objective was to understand how the adoption and use of this technology transforms the farmers, what we presented before, and try to capture this and understand this. So it's part of this 24 interviews. And from the environmental point of view, we conducted 2 life cycle assessments in 2 commercial farms that were equipped. The idea was to look at the role playing by the technology on the environmental impact, of this milk production process. and see how the technology can influence this impact. Yeah, it's okay, you can go. So what have you learned again? So from the social and human costs and benefits, there were clearly expressed benefits like decision-making, enhancing decision-making, facilitating the work organization as well, animal welfare and sustainability, and also farmer well-being and autonomy. So these are these little categories I showed previously. So they they check the boxes. But at the same time, as we say, there are positive and negative aspects of the adoption and use. And it was more about mental strain and new skills, mainly related to the data that was collected, that is daily collected, and it provides a lot of data. And to analyze this data and to extract something useful for them requires new skills and also new support or advices. We can talk about this later. So sometimes it's complex to use. The farmer have also expressed tension between gaining control and autonomy. So that's one of the trade-offs we showed previously with regard to the data. So using the data to separate the flock in batches and then to optimize the feeding process, for example. But on the other hand, feeling a little bit overwhelmed by this technology, the bureaucracy, the numerous areas. So the two examples I showed previously are here illustrated by the verbatims of the farmers. You can go. And from the environmental analysis, we really confirmed the fact that the part of the step of the agricultural process that have most impacts are the feeding process and the animal emissions, so in green and yellow in the bars. And as you can see or not see, the digital technologies, the contribution of the digital technologies. So in this use case, we had the milk meter. These are based on optical and data, but we also included the automatic concentrate distributors. So it's quite hardware as well. But as you can see, they do not or nearly not appear in red in these bars. So in this process, the digital technology has nearly no impact if you look at the whole life cycle. And so the new question we ask is, how can the milk meter associated to the distributor, automatic distributor can provide data to help to optimize the feeding strategy, because the feeding process is the most impactful step of the milk production. And so it changes a little bit the question, and also it is a good question because then we can take all the stakeholders of the living lab and ask this question and ask for example, better advice to organize the feeding strategy, or make some choices in terms of type of food to be delivered, etc. So this was quite an interesting results to share with the stakeholders, and we will do this in the following workshop. Some conclusions, I will read them, Germain, if you want. The idea now is to focus on the analyzing and enhancing the value of this data produced by the meters, and also related to that, to consider also the transformation of the advisory service that were provided until now, before all this data was collected. But now we have this data and all the sector has this data, and how can we transform also the advisory services to work on this data, and also to continue the discussion with all the technology providers in order that they adapt also these technologies to the dairy sheep sectors, because sometimes it comes from other sectors. I thank you. We thank you.
Yes. Thank you very much, Germain and Alexia, for sharing these insights. So now we will move to a discussion and where the audience is welcome to ask some questions. And I will give the floor to Serafin Pazos, who will be moderating the discussion. Serafin, over to you.
Thank you, Merve. Well, we have quite a rich contribution so far, and thank you for all the speakers for the diversity of views and the complementarity of them. But I think you have had a lot from the speakers, and before the speakers perhaps respond to your questions, I wonder if anybody would like to raise your hand and take the floor. I'm happy to pass the questions first, and then we go through a few other things I've seen in the chat. But if anybody would like to have an immediate question, I cannot see all the 67 colleagues at the same time, so I'm sure that Merve and Maite will alert me if anybody will raise a hand. But if not, I have a few questions. A few questions for you. I just while I'm talking to you, I'm just checking in the chat in case there's specific questions, but I don't think that's more general comments than specific questions. So maybe can just to kick off the discussion. I think perhaps we could start by running order with Miguel. If you would like to, I mean, your oh yes, sorry. I think I've seen. I don't know. Sorry. I thought it was a question. My apologies. So Miguel, maybe we can start with you, if you like, perhaps to run up sum up your early contribution about what are in your views, and considering we are moving into a new programming period. Okay, thank you. What I said earlier about everybody's open to raise your hand, but raise your hand not like the mic off, otherwise things can happen. But anyway, so Miguel, since we are moving into a new common agricultural policy, taking stock what you said, what do you think will be the most critical trade-offs in terms of assessing digital farming and addressing the issues about digitalisation and economic performance versus environmental gains or productivity? I mean, essentially, what do you think are the key things that, as we move into a new policy environment with a different way of measuring performance and success, what do you think will be the most critical aspects that colleagues should be looking up in terms of digitalisation of digital farming tools supported by CAP? I mean, this is an open question. We know that this has been negotiated by the Commission, so all the caveats. This is just an open reflection, as it is very much in everybody's minds at the moment.
Yes, thank you very much, and thank you also for the very interesting presentations. Well, maybe I would like to start first with this, to commenting on the very interesting insights that we got from the Living Labs, and then maybe I can complement on the future, let's say, framework. So I think first of all the Living Labs are very valuable because they, let's say, they move us from the potential of the technology, so from a more theoretical framework to this real world conditions. So from a policy perspective, I think this is very important. Maybe I would like to mention here, well, I think it's very positive to see that farmers in the surveys clearly articulate these concrete benefits that we have seen, while at the same time keeping into consideration these trade-offs that we've been discussing. Also, I think it's also very important to keep these trade-offs visible in order to design policies that can help us to overcome these trade-offs. So maybe I would like also to mention, because I referred before to the GRC study on the state of digitalization in the EU. And I think these surveys are very useful in order to complement, let's say, this study and to gain additional evidence and insights on specific sectors, specific technologies, and also across different regions and member states. But apart from this, I wanted to say that maybe it could be interesting to triangulate also with official statistics too, because for instance in Eurostat in the farm structured survey there is well, from 2023 there is a complementary module, there is a machinery module that contains also data on digitalization at farm level. And I was thinking that maybe it could be interesting to somehow cross-check this data from the surveys with the GRC study that I was mentioning, and also with this data from Eurostat, in order to be able to maybe to validate some signals, to highlight also maybe differences across sectors, regions, and also to see where the gaps may exist. So this could be also an interesting way to complement the results. And then finally on the next let's say period, well, as you know, the Commission has put forward a number of proposals. Now we are in the phase of negotiations, so there is still a long process there to be completed. But maybe what I could mention from a policy perspective, as I was explaining before, I think it is crucial to ensure an enabling environment, meaning that for us the digitalization is really a question of supporting the key building blocks. It's not just for instance providing support for adoption or working on the digital infrastructure or in the skills. No, we think it's a matter of ensuring that the main building blocks are there, so farmers can not only incorporate these tools but use them effectively. And here I will finally mention or refer to the GRC study on the long-term implications of the digital transition for agriculture and rural areas. There we have a clear description of what are these main key building blocks, and of course, as I said before, these are mainly proper support for connectivity, digital skills, capacity building, but also digital in the public administration. So this would be, let's say, the main aspects from my side on these points. Thank you.
Thank you. Yeah, I was just thinking that well, I mean, thank you for trying to venture into the future, because you know when we were somebody in the Commission this time of the policy cycle, that's inevitable. So thank you for addressing that. I mean, we're just mentioning about the indicators. You're right. I mean, we need to triangulate with existing indicators and others. For instance, we are looking at the moment on the performance framework, and whether there are the key indicators on digitalization there, whether there are some that could be added that were not there for whatever reason, but that actually be done by member states as an additional indicator to measure progress and success. And of course, the key thing, as you said, is the more difficult to measure, which is the enabling conditions, because the regulatory ones is easy to do, capacity ones more or less, but then when you got like which is something that's very important in this project, is socio-environmental context, which is much more harder to measure, to track, and to define. And that perhaps often what's the key success factor for digitalization. So without further, I'd like to cover at least all the other speakers would like to. So thank you. But I would like to also give the floor to Alexia and Veronique on one particular topic that you mentioned your your presentation, which is about hidden costs of digitalization or the introduction of digital tools. How do you think these hidden costs in terms of data dependency or organizational changes, precisely these enabling conditions that we just discussed a moment ago, in your view, could be better integrated into evaluation frameworks? I mean, what is your ideas about how to address the issue of hidden costs of the introduction of digital tools? Alexia, Veronique, any of you or both of you are more welcome to comment on that.
Yeah, I guess first we have to we have to highlight them, to identify them. This is done by this data collection or this qualitative discussion we have, these interviews we have, because as they are named, they are a little bit hidden. So they are like a second effect or a rebound effect of the adoption and the use of the digital technology. So the first thing is to identify them and then to address them. And sometimes they are like addressing both the environmental or the social and the economic dimension, etc. So we have seen in the social analysis that some of the social costs are directly related to economic parameters. So then to address them and to find solution, I think it's case per case. I mean, it will depend. It will depend on the environmental. Is the socio-economic environmental enabling enough? Is the service provider locally located, etc. So, but I think the challenge first is to identify them, because the farmers, they don't always think that this is a hidden cost. I don't know, Veronique, if you have some comments on that. You're muted. You're muted.
Thank you. So for completing Alexia's view, which is of course identify them, I would like to mention a PhD thesis which just was completed in France about that, and so which makes kind of clusters, and so this is the thesis of Maha Ben Jalahab. So I will put the name, and she identified various types of technologies, and for instance, in softwares, management softwares, there are very little hidden costs, but those hidden costs are much higher in anything which is related to digital tools for like robots, or in which you have big material because you have installation, you have maintenance, accessories, and in that cases, these hidden costs can rise up to 60 to 70%. So I will put the references of this PhD thesis. Actually, it's in French, but now with artificial intelligence, you can translate everything. So she has carried out this study in France on more than 400 digital tools, okay, from FMEIS to robots. And that's what comes up from this 3 years experience. So very valuable insights about that. And
that would be good. I mean, that would be good to have the reference also for our future stages in the project, but also because that can be included in the event report for those who want to well on that. I think you're right, because but that's what we try to do in Horizon, try to unearth new and actually get the researchers in touch with each other and with policymakers. No, but I mean, you're right, because on the question of Alexia, I mean, a lot of things are like qualitative, and you have to do field work, and you have to do a lot of field work and then identify common patterns that can be replicable. But when we start having like this study, which is like large scale, and probably have to combine like a lot of mini field works and case studies into something, we can start to detect patterns. Even on the French side, I mean, I would say that for many countries, if a country as diverse as France has detected certain patterns, can definitely be replicable, or at least, you know, as a good basis to assess the importance of the enabling environments in, for instance, Western Europe. Even that France is very north and southeast and west, so in a way, it's a good proxy in a way. France, but that's very, seriously speaking, very useful thing to know, and definitely we're gonna look into that as well for Codex, as we are doing a number of tools as well on this topic. I think I'd like to, I know we're a bit pressed with time, but yes, I'd like to, out of fairness with everybody, I would like to give Simona and from Ljubljana, or Angelman from IDELE, any final comment about, for instance, conditions of success for digital tools based on your living life experience, any barriers, or essentially any key final key messages that perhaps you thought that when you did the presentation was not sufficiently highlighted, or things you would definitely like the audience to go away with in this event. So, Simona, Germain, if you would like to say some comment, additional comment before we wrap up.
Yes, maybe one final comment from my side, because I also saw in the chat that there was a question about the negative effects in our living lab. So I would like to mention something really practical, which is not really a negative effects, but maybe some challenges that we were facing on. The Doppler winery is a family-owned winery with 3 different generations of farmers. So what we were facing as a challenges was that the older farmers were not so well digitalized, and also didn't have enough knowledge of the digital literacies to face with the challenges when they pop up during the work. Whereas with the daughters or the older family members, they could solve the issue. So sometimes it happened that the problem was something really small, but they couldn't fix it. And how we try to address this is we created a really short practical manual for them. So with all the things that they should make sure are working in order to have a complete set of the whole services in their farm. So this was, let's say, the main challenges that we faced, but we still try to find a solution that it seems to be working well for them. And also to stay for the future, like for after the end of this project, there's not going to be all the time this technical support from our side, from the university, but this will be something that will stay with them for the long term and will help them to really make sure that the technology is working for them. Thank you.
Thank you. No, that's great, and that's actually suggests the things we need to do ourselves in the project to make sure that some of the things we're developing can actually be used by others beyond the project end. But I'd like to move on to Germain. I'd like to have on the same topic some additional comments from your presentation or your early contribution. Thank you.
Yeah, thank you. Maybe something I didn't explain during the presentation because it was highly discussed in other workshops, but not specifically related to the milk meters ones. The farmers are also very looking for new evolution regarding interoperability between tools, because you were mentioning hidden costs. We could say additional costs in each time you buy a technology. You have the price of the technology, but also the subscription, the maintenance, and they are really hoping that there could be some standards or regulation regarding the way that the tools can communicate on a farm, helping them have a useful dashboard or IoT connection between the different technology, even if it's different IT or tech providers, but they are really asking for them to help them to adopt technology. They can see very good benefits or advantages, but this is also something very strong as an obstacle for them. So we are not mentioning it in the presentation, but because speaking only one tech, but when we speak at farm level, we can see this is also an issue for them.
That's helpful, actually bring interesting ideas, because the Commission now is, well, it's been presented already and is working at the moment, the so-called European Competitiveness Compass, which is essentially a strategic agenda to create European standards that are European, not somewhere, and B, that they are interoperable. And there's that the in transport, there's going to be a big push this year, next year on more interoperable systems across Europe. But the same could happen in digitalisation, particularly where we're actually boosting European data and technological sovereignty. So actually, that's a useful comment. I'm probably going to follow up as we're developing the final recommendations for Codex. It's not specifically about Codex, but I think it's an interesting permutation of the things we've been looking at as potential recommendations as this agenda is being shaped up at the moment. So thank you very much, all the speakers, all the contributions, also Professor Brunori for the introduction. I think I'm going to give the floor to Maite, if I'm not mistaken, on this occasion. Yes, I got it right this time. Thank you, Maite. So thank you all for me, and I will give the floor to Maite. Thank you.
Thank you, Serafim. Hello, everyone. My name is Maite Iglesias, and together with my team, I'm in charge of the communication of the Codex project. To close this session, I would first like to thank you all the speakers for sharing their expertise, experience, and perspectives with us today, and also to all the participants for joining us today. Before we finish, I would like to remind you that this event has been organized within the framework of the Codex Knowledge Accelerator. It's a platform designed to facilitate exchange between research, practice, and policy, and to ensure that we all have access to the latest insights, tools, and strategies to address the challenges of the digitalization in agriculture. We kindly ask you to join the Knowledge Accelerator community to follow the work we are doing, stay informed about upcoming activities, and continue this conversation with other people or organizations interested in the future of digital agriculture. The next and last Knowledge Accelerator webinar will be held in May and will be a science policy workshop. Also, the Codex Final Conference will be happening in Brussels on the 15th and 16th of September. So please, I ask you to save the date because more information about these events will be shared very soon. In the meantime, please stay connected. On the Codex website, we will publish today materials, including the presentation and the recordings of the session, as well as the main outcomes and key messages in a highlight report. On behalf of the Codex project, thank you very much for joining us today. We hope to continue the conversation with you all in the future. I wish you all a very nice day. Thank you so much.